Hello to everyone, let's talk about the eigenvectors and eigenvalues. Please don't forget to subscribe and like this video for more content like this. Eigenvectors are vectors that has a special relationship with a matrix A such that the multiplying A times a vector, we get back the same vector times a scalar. So the scalar is our eigenvalues. We have one example here. We have here the matrix A. So to get the, we can start by getting the eigenvalues from this matrix. So we will have here the formula. We have to get the eigenvalues. We need to have A subtracting the scalar or lambda times identity matrix. So we have our A matrix minus lambda multiplying identity matrix. So we'll we'll end up having a lambda in the main diagonal, and the other ends we will have 0. So here now we have the A matrix minus this a matrix that's a result from this multiplication. So now we will have here 2 minus lambda. We will have 280 and 2 minus lambda. So now we have to take the determinant with this of this matrix and set it equal to 0. So and now we will have 2 minus lambda times 2 minus lambda minus 8 times 2. So now we will have this equation, so we can multiply 2 times 2 and 2 times lambda, and lambda times 2 and lambda times lambda minus 80 times 2 equal to 0. And we can simplify this equation and we get this equation. So we need here to factor it, and when we factor it, we end up here. Now we have eigenvalues lambda equal to 60 and lambda equal to negative 2. So now we can have eigenvectors. So to have eigenvectors, we have this formula. So we will have eigenvectors for each of the lambda. So for 6, we will plug in here 60 times identity matrix. So we will have this. We have a matrix and we have lambda 1, lambda 2. So 60 negative 2. So here we plug in 60 and we will end up having a matrix A minus we will have 60 in the main diagonal, and in other end we'll have 0. So we have here now a matrix A minus this the matrix that result from this multiplication. So we will have here minus 4, we will have here 2, we will have here 80, we will have here minus 4. So we can use an we can simplify it by echelon form. So using echelon form, we will get because we had here 2 times this row. We have to remember that the operation that we're performing is this one, where we have here this operation that we already have the result multiplied by times the vector equal to 0. So we have here, and here we will have 0, and here we will multiply negative 4 to, times x1 and plus 2 times x1 equal to 0. So here when we can simplify it, and when we have x2 equal to 2, we will have 1 here, and this will be set to will be 0. The result will be 0. So and here we have our eigenvector 1, 2. So this is a form of the vector. Any multiplier of this vector qualify to be eigenvector. So we have this case, and here we have eigenvector for lambda 6. Let's now plug in our equation negative 2. So here we have a negative 2 plugin times identity matrix. So we do the same operations we did here. We will end up having a minus 2 in the main diagonal, and at the entry we will have 0. So, and now we will subtract 2 minus negative 2 will be 4. 2 will be 8 here, and here will be 4. So using a echelon form, we will end up have this result. And now we have to remember again that what we are solving is this equation, so we need to multiply by x vector, and we set it equal to 0. So we have here, and here we will have 0, and here we will have 4 x1 plus 2x1 equal to 0. When we have 2 minus 2, we will have 2x1 1. So, and here we have the eigenvector. As I said that the multiplier of this vector qualify to be an eigenvector. So here we have eigenvector for second value. Please don't forget to subscribe and like this video for more content like this. Thank you for watching.